Charlie watches a pattern develop. He starts with 3 guppy fish in his fish tank. The next month he finds 6 guppy fish in his tank. The following month he finds 11 in his fish tank. Write an expression to model the pattern of guppy fish in his Charlie's fish tank. So how do I organize this information? I can make a table. And on one side of the table, I have month. And then on the other side, I have the number of fish. So after the first month, how many fish are there? Second month?
6.
And third month? 11. So this is where your graphic organizer comes into play. The question is, which family is this? Linear, quadratic, or exponential? Well, to determine that, I have to think about how do I go from 3 to 6? Plus 3. How do you go from 6 to 11? Plus 5. Okay, I want to go backwards. Let's go back to month 0. What do you think that would be? Plus 1. So, do you see the pattern? 5, 3, 1. So, this number plus 1 gives you 3. So, really, how many fish should you start with? 2. Does that make sense? This number here in light green is called your first common difference. Everyone say first common difference. If it was the same number here, then this would be a linear. What does L stand for, class? Well, do we have the same number here? No, so it's not linear. Okay? Let's now see if it is a second common difference. If it is a second common difference, then the family would be quadratic. How do you go from 1 to 3? Plus 2. And 3 to 5? Plus 2. So I have the same common difference for the second one, so then yes, it is quadratic. Okay? What does the quadratic family tell us? Well, once you create your graphic organizer, you have standard form. Nope, you can just use regular paper. And to find this A value, it tells us find A by taking the second common difference and divide it by 2. Let's do that. A is equal to the common difference divided by 2. And my common difference here was 2. So 2 divided by 2 is 1. A is equal to 1. How can I use the A equals 1? That was back in the standard form that I just showed you. ax squared plus bx plus c. And my A value is 1. And the reason why you go back up to 0, everyone say y-intercept. When you go back up to 0, this is your y-intercept, and this becomes your c value. So you have a plus 2. And this is your answer. 1x plus 2, or do we write the 1 there? No. So the best one you could have had is x squared plus 2. So again, once you know it's quadratic, I know it's quadratic because I have a second common difference. I take that number and divide it by 2. That's my A value. And then in my table, if I work my way backwards up to 0, this is my y-intercept. That is your C value. And that's what you need to write your expression.